Hello guys, welcome to STR8CHEM. In this video, we're going to look at some problem solving regarding to Faraday's law. First of all, we need to look at what does it mean by Faraday's first law. Based on Faraday's first law, it is defined as the mass of substance discharge is directly proportional to the electrical charge in Coulomb. Okay, so the Faraday's first law simply says that the mass of substance discharge is directly proportional to the electric charge in Coulomb. So to calculate the problem solving for the Faraday's first law, we're going to use the formula of Q equals to IT, in which the T over here is the time in second and I is the current in ampere. And also we need to know what does it mean by Faraday's constant F. Over here we can see the relationship. So we can see that 1 mole of electrons equals to 1 Faraday, and 1 Faraday is equals to 96500 Coulomb. So this is a very important relationship that you need to know in order for you to be able to solve problems in Faraday's law. First, we're going to look at the first problem. Over here, the question wants you to calculate the mass of aluminium deposited during the electrolysis of molten aluminium oxides if a current of 5.0 ampere is passed through for 1 hour. We have the time given here. You can see that there's a time over there. And you have the current. And we need to find out the mass of aluminium deposited during the electrolysis of a molten aluminium oxide. So, step 1, what we need to do. First, we're going to use the formula Q equals to IT to find out what is the electrical charge involved in this electrolysis process. So by doing that, you would be able to work out the Coulomb, which is equals to 18000 Coulomb. We have 5 ampere, of which given to you in there. And then it is passed through for 1 hour. We need to change that into seconds. So you have 1 times 60 times 60. Change that into second. And you will multiply that with the current. And you would be able to get your Coulomb. And then in step 2, what we need to do is we need to compare with the relationship that we have learned just now. We do know that 1 Faraday is equivalent to 96500 Coulomb. So how much is that for 18000 Coulomb? Okay, so you have, this is the current that is passing through in this electrolysis in here. And how much is that in Faraday? And over here, you'll get the Faraday. So you'll get 1 mark for this, 1 mark for that, 1 mark for this proportionality, and you'll get 1 mark for finding out the Faraday right there. In step 3, we need to take that information and now we're going to compare with what we have in here. We do know that the aluminium solids will be deposited at the cathode. So the cathode's half reaction will look like this. You're going to have aluminium 3+ in liquid form Why is it in liquid? You need to remember, because just now you have molten aluminium oxide. So when you have molten, the word molten over here, you have the word molten, then your aluminium will be in liquid form. Okay, your aluminium 3 plus will be in liquid form. So aluminium 3 plus 3 moles of electrons getting reduced. This is reduction process, because reduction is gaining of electrons at cathode. So you will reduce that into aluminium solid. And then from there, what you need to do is you need to do another proportionality. This time, you're going to take the information from the cathode half cell. You have 1 mole of aluminium solid being formed. And when you have this being produced at 1 mole, it will involve 3 moles of electrons, like what you are seeing on your screen right here. So 1 mole of aluminium solid is equivalent to 3 moles of electrons. And from where do you get this information from? From the cathode half cell, of which you have written down above. And when you continue with that, you're going to compare with the number of mole of electrons that you have in reality, in the real situation. How much do we have mole of electrons flowing in this electrolytic cell? You have 0.1865 mole of electrons. And from where do you get this? We got it from here. Okay? So when you get the Faraday, 0.1865 Faraday, we would be able to know how much electrons are flowing in this electrolytic cell. So 0.1865 mole of electrons. Do remember this relationship. 1 Faraday is equivalent to 1 mole of electrons. Over here, we have 0.1865 Faraday. And from where do we get this from? From the calculation that we have done in Q equals to IT. So, after you have done this, you should be able to work out the calculation for moles of aluminium solid. Okay, so you're going to do cross multiplication. So 1 times 0.1865 mole of electrons divided by 3. 0.1865 divided by 3. So this is just a very simple cross multiplication. So you're going to find this one. So you're going to do that is times. And when you go up there, that is going to be dividing. Then you get this. And therefore, this is the number of mole of aluminium solid being deposited in the electrolysis. So you get 0.06217. So in exams, you would be able to get 1 mark for this. You get 1 mark for this proportionality. And then you get 1 mark for that. Therefore, in step number 4, we're just going to take the number of moles just now to find out the mass of aluminium solids being deposited. So this is a very basic calculation to change mole into grams. So you take the number of mole of aluminium solids, of which that we have worked out in here, and you times with the molar mass of aluminium, which is 27.0 gram per mole. So that is the molar mass for aluminium. Then you get 1.68 grams of aluminium. Okay, so I'm just going to highlight that. So that is the molar mass of aluminium. For the second question, it gives you aqueous solution of tin salts, which was electrolyzed by an electric current for 2.50 ampere. So that is the current for 3 hours. And the mass of tin deposited at the cathode is 8.3 32 grams. The question wants you to determine the charge of tin as an ion in the electrolysis. Step 1. As usual, we need to do the calculation of Q equals to IT. You are given I, so that is the I, and that is the T. And remember, the time here needs to be changed to seconds. Okay? So this is the coulomb that we have flowing through in this cell. Okay? Q equals to IT. You have 2.5 times 3 times 60 times 60. You get 27,000 coulomb. In step 2, we need to use the proportionality. We want to find out what is the Faraday number for 27,000 coulomb. So by doing that proportionality, you would be able to convert coulomb into Faraday. And then from this information, we would be able to know how much electrons are flowing inside this electrolytic cell. So you'll get 1 mark for this, 1 mark for coulomb, 1 mark for proportionality, and 1 mark for the conversion from coulomb into Faraday. In step 3, we're going to find out the moles of tin because you have the mass of tin being deposited. Okay, you have the mass of tin deposited in cathode is 8.32 grams. We need to change that into mole. So this is exactly what we are doing right here. We take that value of mass and divide that with the molar mass of tin, 119 gram per mole, and we will be able to work out the number of mole of tin being deposited in the electrolysis. So that is the mole of tin deposited. So by writing this, you would be able to get 1 mark for that. Next step, what you need to do is you need to do the proportionality. We know that the tin will be deposited at cathode and the half reactions cathode should be like this. So we don't know what is the oxidation number for tin yet. This is the one that we need to find out. So that is the one that we need to find out. We need to determine the charge of the tin ion. So we're going to leave it as N+. And by finding out how many moles of electrons here, we would be able to find out the oxidation number of the tin. So through the balance cathode half reaction, we can see the relationship. You have 1 mole tin solid. 1 mole of tin solid is equivalent to N mole of electrons. So we're going to compare with the number of mole of tin solid that we have got in here. So we get this number of mole of tin. And we're going to compare with the number of moles of electrons flowing in the electrolytic cell. And from where did we get this number? We got it from here just now. Okay, do you remember that 1 Faraday equals to 1 moles of electron? So if you look here, so since 1 Faraday equals to 1 mole of electrons, so we can write that the number of moles of electrons is 0.2798. And when you do the cross multiplication, you should be able to get the number of moles of electron. If you do this, you can get the n mole of electron. When you take this number and you divide by 0.06992, so n equals to 4. So when n equals to 4, we do know that the number of moles of electrons is 4, and therefore the charge of the tin will be 4 plus. So we know that just now as n plus n mole of electron, and we have found out n equals to 4 from this calculation and from the proportionality over here. And yes, you'll get this one is 1 mark. You'll get 1 mark over here as well. And in step 5, you're going to write the charge of stannum or Sn ions equals to +4 or Sn4 plus. So you get 1 mark here. Now let's have a look at problem solving number 3. For this question, we need to find out the volume of gas being liberated at standard temperature and pressure at the anode. And what is given to us, we have the current 20 ampere pass through an aqueous solution of NaCl for a time of 60 minutes. So we need to find out the volume of gas at standard temperature and pressure at the anodes. Step 1, we will be doing the same thing. Q equals to IT, and you'll get the Coulomb over here. Q equals to IT, 20 right over here, times with 60 minutes. Don't forget, change that minutes into seconds. Then you have the Coulomb right here. Step 2. So we're going to be comparing the 1 Faraday equals to 96500 Coulomb, X Faraday equivalent to 72000 Coulomb. So this number you get from the calculation that you have done over here. So this is the amounts of electrical charge flowing inside this electrolytic cell. So we convert Coulomb into Faraday, and we'll get 0.7461 Faraday. So you'll get 1 mark here, 1 mark here, and that one is 1 mark. This one is 1 mark. So the question gives you that aqueous solution NaCl right here. If you look here, the aqueous solution of NaCl. So when you look at this term, if you are given this term in the question, so we can consider that the concentration of NaCl in this aqueous solution is high, okay? So you have aqueous solution NaCl. The word diluted is not mentioned, so we can consider the solution over here as concentrated. So when you have concentrated solution, so at the anode, what will happen here is you'll have the chloride ion, aqueous, and anode is losing of electrons. So you're going to lose electrons, and you will convert that into chlorine gas. To balance this out, so you're just going to put 2 here and 2 right there. So 2Cl minus aqueous to make to liberate or to release 2 moles of electrons plus chlorine gas. So do remember this. Okay, at the anode, this is what's going to happen now for this aqueous solution of NaCl, because this one is considered as concentrated. So step 3, what we have here, anode. So the anodes over here, this is the one that we have written just now, right there. So we're going to take this because we want to know what is the gas being liberated at anodes. And from the half cell over here, we can extract the information that 1 mole of chlorine gas is equivalent to 2 moles of electrons over here. So we're going to compare the information that we have got from the half cell here with the number of moles of electrons that we have got from here. Okay, do remember, if you get 0.7461 Faraday, that is also going to be the same number of mole of electrons. Okay, do remember that. That is a very important relationship. So you'll get this. Okay, so since 1 Faraday equals to 1 moles of electrons, therefore 0.7461 moles of electrons right here. And we're just going to find out the X mole of chlorine gas being liberated when you have this amount of electrical charge. So when you do cross multiplication, you'll get this. So you get 0.7461 divided by 2, and you get 0.3731 mole. So you get 1 mark for this, 1 mark for this, and 1 mark for that. So moving on to step number 4, what we need to do is to find out the volume at STP, standard temperature and pressure. We're just going to take the constant over here. So this is the number that is constant, 22.4 liter per mole, times with the number of mole of chlorine gas that we have got in here. And you will be able to get the volume of chlorine gas equals to 8.36 liter. So when you do this, you get this one 1 mark and 1 mark. For the last question, problem solving number 4, we have to calculate the time taken in minutes to produce 0.86 grams of chromium from Cr2SO4 to solution by a current of 6.4 ampere. Step number 1. So we're going to find out the number of mole of chromium solid first, of which we have over here. And by doing this, you'll get 1 mark. And then we're going to do in step 2, you're going to find out the number of mole of electrons, or number of moles of electrons being involved, by doing the proportionality based on the half cell reaction that we have got over here, just like what we have done in problem solving number 1, 2, and 3. So we have 1 mark right here. And then since 1 Faraday equals to 1 moles of electrons, and you're going to use this relationship again, we have found out the Faraday, the number of mole over here just now, number of mole of electrons. Do remember, number of moles of electrons equals to 1 Faraday. So you're just going to write 1 Faraday over here. So you get 1 mark, and you'll get the coulomb right here, 1 mark. And then you're going to proceed to step number 4. We're going to use Q equals to IT. So it's just like the opposite of what we're doing in number 1, 2, and 3. So in those questions, we started with Q equals to IT. But in this one, we're going to end the question by Q equals to IT because we want to find the time. So by doing this, so you get 1 mark here. And by finding out that one, you get another 1 mark.